Hello students, after doing ray optics, the second most repeated topic in JEE Mains 2025 was thermodynamics. So from today we will do a few questions on thermodynamics. So पहले क्वेश्चन से शुरुआत करते हैं. क्वेश्चन नंबर 30 22 जनवरी 2025 मॉर्निंग शिफ्ट का. Question is as follows. 1 mole of ideal gas is taken from state A to state B by two different processes. Process 1 is reversible isothermal process, which is an isothermal expansion, and process 2 is a reversible adiabatic expansion. If the final volume of both processes is same and equal to 2V0, where V0 is the initial volume, and the work done in process 1 is W1 and in process 2 is W2, then we have to comment whether W1 is greater than W2 or W1 is less than W2, or is W1 equal to W2, or is W1 equal to gamma times W2. So in order to solve this question, हमको पहले कुछ चीज़ें पता होनी चाहिए आइसोथर्मल और एडियाबैटिक प्रोसेस के बारे में. जैसे पहली बात, आइसोथर्मल प्रोसेस के लिए कैरेक्टरिस्टिक इक्वेशन है PV इज इक्वल टू कॉन्स्टेंट. दिस इज द कैरेक्टरिस्टिक इक्वेशन. If I differentiate this characteristic equation, I will get PdV plus VdP is equal to 0. इस इक्वेशन को हम थोड़ा रीअरेंज अगर करें तो वी विल गेट dP by dV is equal to minus P by V. तो ये एक रिलेशन आ गया अपने पास. सेम थिंग इफ वी डू फॉर एडियाबैटिक प्रोसेस, द कैरेक्टरिस्टिक इक्वेशन ऑफ एडियाबैटिक प्रोसेस इज PV पावर गामा इक्वल टू कॉन्स्टेंट. इसको अगर हम डिफ्रेंशिएट करें दोनों साइड पे, सो विल गेट गामा V टू द पावर ऑफ गामा माइनस 1 PdV प्लस V पावर गामा dP इज इक्वल टू 0. अगर हम V पावर गामा माइनस 1 कॉमन लेके RHS भेज ले तो दैट विल बिकम 0 एंड इट विल गिव अस द रिलेशन गामा PdV प्लस VdP इज इक्वल टू 0 और dP बाई dV इज इक्वल टू माइनस गामा P बाई V. तो इससे हमें ये चीज़ दिख रही है कि स्लोप ऑफ आइसोथर्मल और एडियाबैटिक प्रोसेस अगर हम कंपेयर करें, देन द स्लोप ऑफ एडियाबैटिक कर्व इज मोर. वाई? बिकॉज गामा की वैल्यू 1 से ज़्यादा होती है. गामा इज आइदर 1.67 और 1.4 और 1.33. इन ऑल थ्री केसेस गामा जो है 1 से ज़्यादा है. देयरफॉर द स्लोप ऑफ एडियाबैट विल ऑलवेज बी ग्रेटर देन द स्लोप ऑफ आइसोथर्म, जिसका मतलब है कि एडियाबैटिक कर्व विल ऑलवेज बी स्टीपर. नेक्स्ट लेट अस कंसिडर द PV डायग्राम. अगर हम PV डायग्राम बनाएं तो हमको ऑलरेडी पता है कि वर्क डन बाय आइडियल गैस इज इंटेग्रल PdV विच इज एरिया अंडर द PV डायग्राम. नाउ इफ द एडियाबैट इज स्टीपर, यानी कि अगर एडियाबैटिक प्रोसेस का स्लोप ज़्यादा है तो उसका एरिया अंडर द कर्व कम होगा क्योंकि वो बहुत ही तेज़ी से डिक्रीज होगा, है ना. फॉर द सेम amount on change in volume, change in pressure will be more in the adiabatic curve. Pressure will decrease faster in the adiabatic curve because it's steeper. So the area under the adiabatic curve will be lesser than the area of isothermal curve. Therefore, since the area of isothermal curve is greater than the area of adiabatic curve, work done in the isothermal expansion is always greater than work done in adiabatic expansion. So student, here is a replica question of the previous question that we solved. It is very similar to the previous question. You can pause the video, read the question, kindly attempt this question and put your answers in the comment section. I will be waiting to hear your answers. Now let us move on to the next question. So here is the next question. This is from 23rd January, morning shift, 48th question. An ideal gas undergoes a cyclic process ABCA as shown in the PV diagram. The coordinates are A of V0, 2P0, B of 3V0, P0, and C of V0, P0. The work done in the complete cycle is. So here we have a cyclic process and they have given the coordinates of A, which is A of V0, 2P0. They have given the coordinates of B, which is 3V0, P0. And they have given the coordinates of C, which is V0, P0. So the process is ABCA. Therefore, we can say it is a clockwise cycle. Now, in always clockwise cycle, work done will be positive. Why will it be positive? Because when the gas is expanding, you see the area under the graph. Let us just consider the process AB. So when the gas is expanding, the area under the graph is more. However, when the gas is compressing, which is the process BC or CB, the area under the curve is less. So work done during expansion is always greater than work done during compression. Therefore, whenever we have a clockwise cycle, our final area is always positive. And you can remember, work done in cyclic process is equal to area enclosed by the cycle. So whatever is the area enclosed by the cycle, this area, that is the work. Now this area is a triangle. To find the area of triangle, we can find its length of the sides, the height of the triangle. Clearly is the difference between the y coordinates, which is P0, and the base of the triangle, which is the difference in the x coordinate, which is 2v0. So work done will be equal to half into base is 2v0 into height is p0, which is equal to simply p0 v0. So first option is the answer. Another very important question that is recurring in all the shifts is question based on the specific thermodynamic processes. To be more clear, here we are talking about adiabatic process. Let's go into question number 33 of the 24th January 2025 shift. It says, a quantity of ideal gas at 27 degrees Celsius is compressed adiabatically to 1/8 of its initial volume. If gamma is equal to 5 divided by 3, the final temperature of the gas is. So among the four options, we have to find the final temperature of the gas. अब ये क्वेश्चन स्पेसिफिकली एडियाबैटिक प्रोसेस का है, तो हम इसमें सॉल्यूशन के तौर पे एडियाबैटिक प्रोसेस का कैरेक्टरिस्टिक इक्वेशन यूज करेंगे. सो फॉर एडियाबैटिक प्रोसेस, the equation, or to say the characteristic equation, is PV to the power of gamma is equal to constant, or P1 V1 to the power of gamma minus 1 is equal to P2 V2 to the power of gamma minus 1. Now you can also remember the alternate forms of the characteristic equation. How do we obtain the alternate forms? For example, here in this question, you have volume and temperature whose relation is being asked. So we need to eliminate pressure. So what you can do is you can write P is equal to nRT by V from the ideal gas equation. So when we do that, what do we get? We get nRT by V into V to the power of gamma equal to constant, or we have TV to the power of gamma minus 1 is equal to constant. In other words, we can write T1 V1 to the power of gamma minus 1 is equal to T2 V2 to the power of gamma minus 1. Now in question, they have already given T1 to be 27 degrees Celsius, which is also in Kelvin, 300 Kelvin. Do not forget to convert into Kelvin. Kelvin is the SI unit of temperature. And if I take V1 as V0, that implies V2, or the final volume, is V0 divided by 8. This is the information given to us. So putting these value, we have 300 into V0 to the power of gamma is given to be 5 by 3 minus 1. 5 by 3 is gamma, so minus 1 is equal to T2, no idea what it is, so we need to find that, into V2, which is given to be as V0 by 8 to the power of gamma minus 1. Again, gamma is 5 by 3. So we will substitute gamma minus 1 as 5 by 3 minus 1. So here T2 will be equal to, we can cancel out V0 to the power of 5 by 3 minus 1 and V0 to the power of 5 by 3 minus 1 on both sides. You will just have 8 to the power of 5 by 3 minus 1 is 2 by 3 into 300, which is 4 times 300. Our answer will be 1200 Kelvin. which is nothing but option number 1. In this particular question, since it's adiabatic process, we are using the characteristic equation of adiabatic process. But in mains, many times they ask about other processes also, like isothermal, isochoric, isobaric. So kindly know the characteristic equation of all these processes. Thank you very much for watching. I'll see you all next time.